So here's part 2 of the combined gas law video showing additional practice problems. So in this problem, we have, in example 3, we have a helium balloon, has a volume of 1.40 liters at 35 degrees Celsius and 110 kilopascals. We're asked what would the volume be at STP, assume that there are no leaks. So as always, I'm going to start by filling in my IFE 123 table. A helium balloon has a volume of 1.4 liters at 35 degrees Celsius. So we're going to add 273 to convert that into Kelvin. And when we do, I get 308. So I'm going to plug 308 Kelvin into my table. And then we also have 110 kilopascals. What would the volume be at STP? So what would the volume be? So we're looking for volume, standard temperature, and pressure. Well, standard temperature is always 273 Kelvin. If you forget that, you can always check back in on page 1 of your reference tables. Page 1, we're also going to need to determine the final pressure because we're told STP, but we're also provided with a unit for pressure, in this case kilopascals. So I'm going to need to use 101.3 as my value for standard pressure so that my units will match. We're now ready to fill in row 3, the effect row. Pressure went down from 110 to 101, and pressure and volume do opposite things. So the pressure is going to be pushing the volume up. But the temperature also went down from 308 to 273, and temperature and volume do the same thing. When things cool, they contract. So the temperature is pushing the volume down. This prediction is really tricky because both the pressure and the temperature are changing by about 10%. So we're going to have to see what the math comes out as far as the actual change in volume. Now that I filled in my IFE table, I'm ready for part 2 of this process to plan out where everything goes. We were told that we're looking for the new volume, so we need to isolate that, get it by itself. We'll move P2 across into the denominator and T2 across diagonally into the numerator, which leaves us with P1 V1 T2 over T1 P2. And V2, of course, is left all by itself on the other side of the equal sign. So I'm going to set up my railroad tracks and move into step 3, calculate. My P1 from my IFE table was 110 kilopascals. My V1 was 1.4 liters, and my T2 was 273 Kelvin. My T1 was 308 Kelvin, and my P2 was 101.3 kilopascals. I'm going to double check my units, make sure things cancel. So I've got kilopascals on top and on bottom, so those will cancel. I've also got Kelvin on top and on bottom. Those will also cancel. The only unit remaining is liters. So that will be the unit of my answer. When I plug 110 times 1.4 times 273 divided by 308 divided by 101.3 into my calculator says that my answer is 1.34 liters. As always, I must go back to the original problem and check for significant figures. So 1.40 has 3 sig figs. 110.0 has 4 sig figs. However, 35 only has 2 sig figs. Again, when looking at your significant figures, you need to go back to the problem and not to your IFE table for this exact reason. When we change 35 into Kelvin, it becomes 308, which has 3 sig figs. But it was not presented as 308 in the problem. It was presented as 35 degrees Celsius in the problem. And so we must go back to the original problem to determine significant figures. So I'm going to get to keep my 1 and my 3. I have to look at my 4 to decide which way to round. 4 is less than 5, so we're going to be rounding down here, and I would present my final answer as 1.3 liters. So it turns out that there was just a very slight decrease in the volume here, with the pressure pushing the volume up and the temperature pushing the volume down. For the last problem, we're going to do something slightly different, a self-check. So I'm going to read the problem, and then I want you to pause the video and try and work the problem on your own. Once you have an answer, you can then play the video again and see how your work compared to mine. So here's the problem. A toy balloon has an internal pressure of 1.05 atmospheres and a volume of 5 liters at 20 degrees Celsius. What will happen to the volume of the balloon if it escapes and rises to an altitude where the pressure is 0.65 atmospheres and the temperature is negative 15 degrees Celsius? So I'll go ahead and pause the video now and work out this problem. Once you're done, you should hit play again. Okay, so now that you're back and ready to check your work, let's start with step 1, the IFE 123 table. A toy balloon has an internal pressure of 1.05 atmospheres and a volume of 5 liters at 20 degrees Celsius. So we're going to take that 20, add 273 to convert it to Kelvin, and we will get to 93 Kelvin, which we can then put into our temperature. We are asked what will happen to the volume of the balloon if it escapes and rises to an altitude where the pressure is 0.65 atmospheres and the temperature is minus 15 degrees Celsius. So again, we're going to add 273, convert to Kelvin, and I got 258 as my Kelvin temperature. So I'm going to put that into the table, and I'm ready to make my predictions. The pressure went down pretty dramatically. Pressure and volume do opposite things, so that means the pressure is pushing the volume up. Temperature, on the other hand, also went down. And since temperature and volume do the same thing, that means that the temperature is pushing the volume down. So again, we're in a situation where the pressure and the temperature are pushing the volume in opposite directions. In this case, the pressure changed by almost 40%. The temperature did not change quite as much. So I'm going to predict that the pressure is going to be more successful in pushing the volume up than the temperature in pushing the volume down. So I'm going to come down and move on to step 2, rearranging the problem. I am looking for my second volume. So that means I'm going to move pressure and temperature across diagonally. Once again, that leaves me with P1, V1, and T2 in my numerator, T1 and P2 in my denominator to find my second volume. Now I'm ready to move on to my railroad tracks and calculations. So I'm going to grab P1 from my table. I'm going to grab V1 from my table. I'm going to grab T2 from my table. Then I'm going to grab T1 from my table and P2 from my table. As always, I need to check what units cancel. Atmospheres on top and on bottom, Kelvin on top and on bottom, which means that my answer is going to be in liters. When I multiply across the top and divide the bottom, my calculator says that the answer is 7.1121. I need to check for significant figures like I always do. So I'm going to go back to the problem and check it out. We got 3 sig figs over here, 2 over here, 3 over here, 2 over here, and 3 over here. 2 is the smaller number, so I'm going to need to use 2 significant figures in my answer. So I'm going to go back to my calculator response, and I am going to be able to keep my 7 and my 1, and then I need to look at the next digit to decide which way to round. 1 is less than 5, so I'm going to round down and report my answer as 7.1 liters. As I thought, the change in pressure was more successful in pushing the volume up, even though the temperature was pushing the volume in the opposite direction. So in these 2 videos, we have learned how to use the combined gas law. Remember that the 3 steps are to organize the information using the IFE table, 2, to plan out what goes where by rearranging the equation, a very important step. Don't try to skip that step. And then finally to calculate the answer using our railroad tracks and calculators. Thank you very much and have a nice day.